subtracting with decimals. We're going to follow the same procedure as addition. We're going to line up the decimal points first and then subtract as normal. In this case, I have 0 and 8/10 minus 0 and 2/10. So I'll line up the decimal points and then subtract as normal. Bring the decimal down. 8 minus 2 is 6. 0 minus 0 is 0. So 8/10 minus 2/10 would be 6/10. Over here, we're going to follow the same procedure. Line up the decimal points. Bring the decimal down. And then subtract as normal. 5 minus 3 is 2. 7 minus 2 is 5. So 7 and 5/10 minus 2 and 3/10 equals 5 and 2/10. Over here, we now have two different size decimals. This one only goes to the 10ths place, and this one goes to the 100ths place. So just like with addition, I'm going to need to add a 0. I'm going to line up my decimal points first and see that this digit, there's only one digit to the right of the decimal in this first number. There's 2 digits to the right here. So I need to add a 0 here. You can't just bring the 9 down. Bring the decimal down, and now we'll subtract as normal. Can I take 9 away from 0? No, I can only take 9 away from something greater than 9. So I need to borrow from this 5, which will become a 4. And now this 0 becomes a 10. 10 minus 9 is 1. 4 minus 3 is 1. 7 minus 8. I can't take 8 away from 7. I can only take 8 away from something more than 8. So I'm going to borrow a 1 from here, turning this 8 into a 7. And this 7 now becomes 17. I've borrowed 10. 17 minus 8 is 9. 7 minus nothing is 7. And 1 minus nothing is 1. So 187 and 5/10 minus 8 and 39 100ths equals 179 and 11 100ths. We'll also go through the same process here. We'll stack the two numbers up, always putting the larger digits on top. So the number that is larger here, 187 was larger than 8. Ooh, I skipped one over here. Let's do that one now first. 8 and 2/10 minus 5 and 6 1,000ths. 8 is larger than 5. When we're subtracting here, we're only going to get positive numbers. We won't be getting negative numbers. So 8.2, and we are going to subtract 5.006. We should see that I now need to add 2 zeros to the number on top, so they both have an equal number of digits to the right of the decimal point. I can't take 6 away from 0. I'd have to borrow from it, from the next number, and this number is a 10. So I'm going to make this 10 into a 9 and borrow 1 from there. But if I borrow from here, this now needs to become a 1. This number here was 200, and I rewrote it as 190 plus a 10, which is also equal to 200. 10 minus 6 is 4. 9 minus 0 is 9. 1 minus 2 is 1. I forgot to bring my decimal point down. And 8 minus 5 is 3. So 8 and 2/10 minus 5 and 6 1,000ths is 3 and 194 thousandths. I'll follow the same process here as above. 632.021 minus, I'm going to line up the decimal point, so 295.9. And I'm always going to fill in the remaining decimal places with zeros so that both the digits involved in my subtraction, or both the numbers involved in my subtraction, have the same number of digits to the right of the decimal point. 1 minus 0 is 1. 2 minus 0 is 2. I can't take 9 away from 0, so I have to borrow from the place over. This 2 becomes a 1, and this 0 now becomes a 10. 10 minus 9 is 1, and there goes my decimal point. I can't take 5 away from 1, so I need to borrow another 10 from this number over here. So this 3 becomes a 2, and this 1 now becomes an 11. 11 minus 5 is 6. I can't take 9 away from 2, so I have to borrow from here. This 6 becomes a 5, and this 2 becomes a 12. 12 minus 9 is 3. 5 minus 2 is also 3. So 632 and 21 thousandths minus 295 and 9 tenths equals 336 and 121 thousandths. It's a good idea, if you don't trust yourself with subtraction, like I don't, to check it with addition. So if you wanted to, you could add these two numbers and they should equal this number. Add these two numbers and it should equal this number. Add these two numbers and it should equal this number. Add these two numbers and it should equal this number. Add these two numbers and it should equal this number.